Today we are going to study the naming system for ketones. In case of ketones, the representation is RCOR. Carbonyl group contain two alkyl group on its both sides. These two R's may be two alkyl group, may be two aryl group, may be one alkyl and one aryl group. So when we want to name ketones, we want to name common names or trivial names to the ketones. We must have to concentrate on these two alkyl groups attached to your ketone. See here, all these are the examples of simple ketone. Watch carefully. This is CO, carbonyl group, and on both sides there are both methyl groups. Here on both sides of carbonyl group there are ethyl groups. Here carbonyl group, here and here there is phenyl group C6H5 means benzene ring, phenyl group. Here on both sides there is benzyl group. So all these are the examples of simple ketone. When you want to write the common name of simple ketone, you must have to write di, then name of alkyl group and then word ketone. Means here you will write dimethyl ketone, right? While if the two alkyl groups are different, if these two are attached to carbonyl groups are different, then those are the mixed ketone. See here, CO. See on both sides of CO, here methyl group, here ethyl group. Here methyl group, here 3 carbon means N-propyl group. Here ethyl group, here propyl group. Means both the alkyl groups are different. In such a case, means in mixed ketone, always follow the alphabetical order of your alkyl group and then write the word ketone. Means see here, methyl group and ethyl group get attached to your ketonic group. So, alphabetically E comes first, M comes later. So, you will name it as ethyl, methyl and then what? Ketone. But if there are certain substituents or the alkyl group is substituted having certain side branch, then the position of side branch should be indicated by your Greek alphabets as alpha, beta, gamma and so on. So let's name all these compounds one by focusing only on the board. So concentrate very carefully and watch the video up till last if you want to understand chemistry detail and in a proper way. Now let's name this first compound. This is your ketonic group CH3 and CH3. So I will write here dimethyl ketone. Di, then alkyl and then word ketone. See here for second structure, watch carefully on both sides ethyl group is there C2H5. So I will write diethyl ketone. While here on both sides phenyl group is there C6H5. In spite of benzene ring, I write formula C6H5. So its name is diphenyl ketone. Okay. Benzene ring with CH2 is benzyl group. That's why on both sides of CO, benzyl group is there. That's why we will name the compound as dibenzyl ketone. While in this last This is your CO. On this side, 1, 2, 3 means propyl group. On this side also, 1, 2, 3 means propyl group. But 3 carbon are not in straight chain. That's why this is isopropyl. Second carbon, secondary carbon get attached to CO. So isopropyl, isopropyl. That's why I will write 2 times isopropyl groups. So di isopropyl ketone. Now let's write the IUPAC names of these compounds which are mixed ketone. See here, methyl and ethyl group on two sides of your ketonic group. Follow the alphabetical order. E comes first, so its name is ethyl, methyl, ketone. Secondly, methyl, and this is N-propyl. That's why alphabetically M comes first. So the name is methyl N-propyl. Ketone. Okay. See here, this is ketone, this side ethyl group, and this is N-propyl. Alphabetically, E comes first, so the name is ethyl N-propyl ketone. Okay. Ketonic group, here methyl group, and this is isobutyl. 1, 2, 3, 4 carbon. One carbon is in a side branch at second position. That's why this is isobutyl, and this is methyl. Alphabetically this come first, so the name is isobutyl methyl ketone. Look here, this is phenyl ring and this is methyl. Alphabetically M comes first. That's why the name is methyl phenyl ketone. Look here, this is ketonic group. On this side ethyl and on this side benzyl. Phenyl ring with CH2. Benzyl, and this is ethyl. Alphabetically benzyl comes first. So alphabetical order of alkyl group and then write the word ketone. So the name is benzyl ethyl ketone. Now in this structure, on this side N-propyl group and this side substituted ethyl. 2 carbons so ethyl, but 1 H is substituted by Br. That's why this carbon is alpha next to functional group. So alpha. The name of alkyl group is alpha bromoethyl, and this is N-propyl. So the name is alpha bromo ethyl, that is N-propyl. N-propyl, and followed by word ketone. Okay, see now friends, we have seen the common name of all these compounds. Now all these compounds IUPAC names we have to study. Now before to start the IUPAC names, keep in mind certain rules. and later on we will name all these compounds one by one. So see here, the first rule of IUPAC, always you know, that is select longest continuous carbon chain containing carbonyl group. Then number the carbon atoms from the end which is close to CO. Decide parent alkane. From parent alkane, E from the spelling is replaced by ONE. Means ketones are named as alkanones. Now, if there are any substituents, then substituents are arranged in alphabetical order and written along with their position, that is locants. So all these rules we will study one by one when we name these compounds. So let's start. See here. First compound, 1, 2, 3 carbon atoms are there. That's why you may number from any side, maybe from this, maybe from this, because CO is at second position. So 1, 2, 3 means it is propane, and hence the name of compound is propan. E is replaced by ONE, so propanone. Okay. See second, 1, 2, 3, 4, 5. 5 carbon. From this side also CO at third position. From this side also CO at third position. That's why you may number from any side. Total carbon are 5. Position of CO third. That's why the name of parent alkane pentane. E replaced by ONE with position of CO. So 3 ONE. Pentane 3 ONE. Look here. CO in middle and on both sides there is benzene ring. So we can't number the carbon atom here because this is also ring, this is also ring. Here you may write C6H5, C6H5. Okay. So the name of this compound is given as benzophenone. Okay. See the name is benzophenone. Okay. Look here. Now rings are here, but in middle of that there is carbon chain also. So number the carbon atoms in a chain. You get 1, 2, 3. Total carbons are 3. At one position, phenyl ring. At third position, phenyl ring. And parent alkane, 3 carbons, so propane. So first write the substituent. So I will write 2 substituents are there. So the name is 1, 3 diphenyl. 1, 3 diphenyl propane 2 ONE. Name of compound 1,3 diphenyl propane 2 ONE. See this example. 1, 2, 3, 4, 5 carbon. From this side also CO at third position. From this side also CO at third position. From this side branch second position. From this side branch second position. So I may number from any side. Number the carbon atoms. See what we get. 1, 2, 3, 4 and 5. Means the parent alkane is pentane. Now substituents are there at 2 and 4 position. Write them together. So I will write, see properly, 2, 4 dimethyl 5 carbon, so pentane. E is replaced by ONE, locant 3 because CO is at third position, 3 ONE. 2,4 dimethyl 2,4 dimethyl pentane 3 ONE is the IUPAC name of this compound. Similarly, see all these compounds now. Now let's name these compounds. 4 carbon, CO close from this end. So 1, 2, 3, 4. Hence the name is butane. E replaced by ONE. Position 2 ONE. Butane 2 ONE. Look here. 1, 2, 3, 4, 5. From this side CO is closed. So 1, 2, 3, 4, 5. Hence pentane position 2 ONE. See here. 1, 2, 3. From this side CO at third position. 1, 2, 3, 4. From this side it is at fourth position. So we must number from this side. 1, 2, 3, 4, 5, 6. Hence parent alkane hexane. E replaced by ONE. Position 3. Hexane 3 ONE. See this compound. It is having substituent. From this side CO is at fourth position. From this side at second position. So in this compound, number from left to right. 1, 2, 3, 4, 5. At fourth position there is methyl. So indicate first substituent 4 dash methyl. 2 position CO, total carbon 5, that's why pentane. At 2 position CO, so replace E by ONE, 2 ONE. Name of compound 4-methyl pentane 2 ONE. Look here, benzene ring, and to that CH3CO is attached. It is named as acetophenone. Keep in mind the name. It is named as acetophenone, as this is having aromatic ring. Rule is slightly different. See here. Select a chain of carbon atom. 1, 2, 3, 4 carbon. This side CO at third position. From this side CO is at second position. So I will number from this side 1, 2, 3 and 4. Here phenyl ring is a substituent which is at first position. That's why first write the substituent 1 dash phenyl. Okay, 1 dash phenyl. 4 carbon, so butane. E replaced by ONE, position 2 ONE. So the name of compound 1 phenyl butane 2 ONE. Look here, 1, 2, 3, 4. 4 position CO, 1, 2, 3, third position CO. So we must number from this side. So number it 1, 2, 3, 4, 5 and 6. Okay. Total carbon 6. At 2 position substituent Br. 2 bromo. Locant 2 bromo. Total carbon 6. So hexane. E replaced by ONE and position of CO3. So hexane 3ONE. Okay, so these are the IUPAC names of this compound. Now see, these are the few more examples having certain changes. Here double bond is present. In this structure, two ketonic groups. This is bond line formula, and in this structure there is ketonic group along with carboxylic group. So let's start how to name these compounds. Look here, as usual, follow your rules. Count the number of carbon atoms, number the carbon from end which is close to CO. So I numbered from right to left. 1, 2, 3, 4, 5. 5 carbon are there. Indicate first the substituent along with its locant. So I will write 4-methyl, right? Total carbon 5, hence pent. At third position there is double bond, so 3 in En. Then at second position Co, so dash ONE, means 2ONE. Okay, see the second one, number from any side because functional group is at second position. 1, 2, 3, 4. Mind well that when functional groups are more than one, write complete spelling of alkane. Hence, I will write butane, complete spelling. 2, 3 at 2 and 3 position. Two ketonic groups are there, so di and ONE. So the name of compound butane 2,3-diol. See this structure, bond line formula, but even though very simple. See, you may name it or number it from this side because it is close to CO. So 1, 2, 3, 4, 5 and 6. Total carbon 6. Bond line formula we have seen in 11th. Total 6. Here is the CH3 which is the substituent. That's why first indicate the substituent. So I will write 4-methyl at 4 position methyl group. So 4-methyl. Total carbon are 6. Hence hex. At in between 3 and 4 there is double bond. So lowest token 3-En, right? And ONE at second position. So dash 2-ONE. You may write it in one line continuously. Due to lack of space, I write it below. Okay. See this. When more than one functional group is present, then decide the priority group. In 11th, we have seen the priority series. The higher priority is given to COOH, and hence I will number from this side 1, 2, 3, 4 and 5. As higher priority group is your COOH, this CO will be treated as prefix and oxo. Note it very carefully. This is a group of lower priority and this is group of higher priority. So I will name on the basis of higher priority group. Okay. So the total carbon are 5. The third position Cu group is present. So it is treated as prefix. So 3-oxo. When it is used as prefix as it is lower priority group 3-oxo. Okay, 3-oxo, 5 carbon, hence pentane. E is replaced by OIC acid. So pentanoic acid. So the name is 3-oxo-pentanoic acid. Now see here, this is alicyclic compound, that is cyclohexane. And in alicyclic compound, the carbonyl group should be numbered 1. So I number here 1. Number in a clockwise direction because CH3 is a substituent and they are close in the clockwise direction. If you number from this side, the substituent will get higher number. That's why number in a clockwise direction. At 2 and 4 position, methyl groups are there. That's why I will write it as 2, 4 dimethyl cyclohexanone. 2,4-dimethyl cyclohexanone. So this bond line formula I simplified to understand. Okay, see CH3, CH2, CH2, CO, 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 CH3, CH3, CH2, here CH, this is side branch CH2, CH3 and this is CH2, CH3. Okay, now number from the side which is close to functional group. So I must number from this side. Okay, you may number here 1, 2, 3, 4, 5, 6, 7. This is a long chain. So 8, 9 and 10. Means it is decane. As 2 functional groups are there, CO, CO, both are same. We must have to write the complete spelling of decane. Before that, write the substituents. See, your substituents are at 5, 5. This is substituent. This is substituent. And this is also substituent. Okay. So, methyl, methyl and ethyl. Alphabetically E comes first. That's why I will name it as, see carefully, 7-ethyl, 5,5-dimethyl, 7-ethyl, 5,5-dimethyl, complete alkane, that is decane. So, decane, write complete spelling. At 3 and 4 position, ketonic group is there. That's why 3, 4 dione, D-I-O-N-E. So 7-ethyl, 5,5-7-ethyl, 5,5-dimethyl, decane, 3,4-dione is the IUPAC name of this bond line structure.